Welcome to Ask and Learn.
In this question, we're looking at a hydrocarbon sample. For A, what is the mass of the hydrocarbon sample that was combusted? We'll first solve for the mass of carbon. We're told that it is 21.83 grams of carbon dioxide. So 44.0 grams of CO2 in 1 mole of CO2. And 1 mole of CO2. We have 1 mole of carbon, and 1 mole of carbon, there's 12 grams. This is molar mass, so the mass of carbon works out to 5.9536 grams. And we'll calculate the mass of hydrogen. And we're told that there's 4.47 grams of water. Grams present in 1 mole, 1 mole of H2O, 2 moles of hydrogen, 1 mole of hydrogen is 1 gram. We'll find that this is equal to 0.5016 grams of hydrogen. So the total mass of the hydrocarbon is equal to 5.9536 grams due to carbon and 0.5016 grams due to hydrogen, and this works out to 6.455 grams would be the mass of the hydrocarbon. For B, we're asked to determine the empirical formula of the hydrocarbon. So we know that we have 5.9536 grams of carbon. Solve for number of moles here. This is equal to 0.4961 moles of carbon and 0.5016 grams of hydrogen times 1 gram in 1 mole, 0.5016 moles of hydrogen, and dividing here by 0.4961, we get 1 and 1. Therefore, our empirical formula here for this hydrocarbon is equal to C1H1, or just CH. For C, calculate the enthalpy of formation per the empirical formula. So for C, we have CH solid plus O2. That would produce CO2 gas and H2O gas. The enthalpy of the reaction is equal to the enthalpy of formation for the products minus the enthalpy formation of the reactants. And this would be equal to delta H naught formation CO2 gas plus delta H naught formation H2O gas minus delta H naught formation CH solid plus delta H naught formation O2 gas. Plug in our values here. And hydrocarbons, so we're told that the enthalpy is 311 kilojoules. The delta H naught of formation of CO2 so let's come back to this in a minute here. The delta H naught formation of CO2 is equal to 21.83 grams. .0 grams in 1 mole. 1 mole of CO2 is minus 393.5 kilojoules. And this would be equal to negative 190 or negative 195.18 kilojoules. And we also have to calculate the delta H naught formation H2O gas. This is 4.47 grams of H2O, 18.0 grams of H2O in 1 mole. 1 mole of H2O is negative 241.82 kilojoules, and this is equal to negative 59.9 kilojoules. And now substituting this into our equation up above here, our delta H naught of reaction. Delta H naught of reaction is equal to negative 311 kilojoules. This is equal to delta H naught formation of CO2 is negative 195.18 kilojoules plus delta H naught formation of O2 is negative 59.9 kilojoules minus the delta H naught formation of CH solid. The delta H naught formation of O2 is 0. So solving this for the delta H naught formation of CH solid, we find that this is equal to negative 55.92 kilojoules, and so negative 55.92 kilojoules divided by the total mass of the hydrocarbon, which is 6.455 grams, times 1 CH unit is equal to 13.0 grams. This works out to negative 112.8 kilojoules per CH unit. And this would be the value of the delta H naught formation per empirical formula unit of the hydrocarbon. And lastly, for D, do you think that the hydrocarbon is one of those listed in Appendix C? So the value, looking at Appendix C, of delta H naught formation for this hydrocarbon matches with that of acetylene in Appendix C.